Okay, so now we're going to start part 2 video of 9.6, inverse trigonometric functions. Okay, so what we're going to do is look at 7, 8, 9, 10, and 11 in this video in your note packet on page 271. So the first thing we need to realize is look at what they're asking for. What are they wanting us to find? So for number 7, they're asking for 3 things. We're asking to find the hypotenuse. Number 2, we're going to find angle C. And then number 3, we are going to find angle A. All right, so those are the 3 things that we're going to do. So let's take and draw our right triangle. There's B, this is 6, this is 12, A and C. And the hypotenuse, I'm just going to call X for the time being since we don't know what it is, or you could call it C. So for step 1, what we have to do is use Pythagorean Theorem. So just a refresher, C squared equals A squared plus B squared. Or A squared plus B squared equals C squared, depending on however you remembered it. So I'm going to have C squared equals 6 squared plus 12 squared. So C squared equals 36 plus 144. When you sum those two, you're going to get 180. Now, you're going to leave that as a radical, or you can turn it into decimal. For our purposes, we are going to show it as a radical for our final answer, but then utilize the decimal part to get our work. So 13.4 is what X is going to equal. Now, for number 2, I'm asking to find angle C. Now, angle C is up here, all right? We are going to have to use tan to get this. So we know it's the inverse of tan. So let me label that as number 1. So number 2, we need to find angle C, which is going to utilize tan -1. So that is opposite over adjacent. And we're using this opposed to sine or cosine because we do not have the hypotenuse. Okay, we could use the one that we solved for, but we have 2 solid numbers here. So using the inverse of tan will give us a more precise answer. So what we're going to do here is actually put this in as a ratio. So tan -1 is going to be times the opposite of C is 6, the adjacent is 12. So now we're going to plug this into our calculator. So we're going to do second tan, and I'm just going to put 6 divided by 12 in there. It will do the work for you. So that means that the measure of angle C is going to end up being 26.6 degrees. Remember, we're rounding it to the nearest tenth. Now, the last one we're asking for is find angle A. Well, folks, we do not have to go back to the beginning and do sine cosine again. We can use the complementary supplementary. So this is going to be a complementary because it's 90 degrees. So we're going to take the 90 minus 26.6, which means that the measure of angle A is going to be 63.4. Now, some of you may be asking, why did we use the complementary instead of going back and using the tan function again? Okay, here's the reason. Part of this has to go back to the fact that we learned in our previous lesson about sine, cosine, and their complementary, supplementary attributes. Complementary, we know, means 90 degrees. If we have a 90 here, the other 2 angles have to add an equal 90 because 90 plus 90 gives me the 180 that's required for a triangle. So that's why we can jump in and use this opposed to going back and doing the whole sine cosine thing again. All right, so that's number 7. And we're going to do this for number 8 also. So basically we're going to use these for all 3, but which one we use is going to be a little different. So the first 2, so number 8, I want you to set up. We are still trying to find the hypotenuse for this one. Let me get the right paper here. Took my eye off the prize for just a moment. So we are looking for the hypotenuse, which is actually ED. And I probably should have put this up here. This was AC. So we found AC over here in our number 7. So we have ED here. Number 2 is find the measure of angle D. And then number 3 is find the measure of angle C. So here is our triangle. It is a right again. This is C, E, and D. We are told the hypotenuse, which is 75, and the shortest leg, which is 21. So now we have to find the line segment of ED. To do this, we are going to take and use Pythagorean Theorem again. So for place 1, C squared equals A squared plus B squared. So this is going to be 75 squared equals 21 squared plus B squared. So 75 squared is going to end up being, let me find it here, 5625. So 5625 equals 441 plus B squared. We're going to subtract 441 across, which gives us 5184 equals B squared. When I square root this, it actually is a perfect square root. It is 72. So that means the line segment is now going to be labeled as 72. And over here, I'm going to write ED equals. So now we're going to do part 2. So part 2 is a little easier if I know that. So for part 2, we're going to use the find the angle of D. So we're going to use tan again. So tan -1. So we're going to actually use the 72 because it's a whole number and not a radical. So if we start with D, we look across and do the opposite over, once again, the adjacent. So opposite over adjacent is 21 over 72. So the measure of angle D is going to equal, well, let's put this in our calculator. So we have second tan 21 divided by 72, which is going to give me 16.3 degrees. Now, to get the other part, which is going to be part 3, so we're going to look for measure angle C. We are going to do 90 minus 16.3. And when we do that, it's going to end up being positive 73.7. So the measure of angle C equals 73.7 degrees. All right, so that's how we do number 8. So if you didn't pause it before and work through it, you could. So for number 9 and 10, these are 2 different things that we are looking for. So we're not going to treat them the same as 7 and 8. So for number 9, once again, we have this lovely triangle. There's my right angle. This is Y. This is X. This way we have it labeled. This is N, M, and L. And I'm giving you 52. So one of them is to find the measure of the missing angle. So in this case, I already have this set up. So for number 1 step, we're going to find measure angle N. Number 2 is find LM, and then number 3 is going to be find MN. So that's basically what we're going to do in this particular problem. So this one up here is 3, by the way, for the measurement. So to do number 1, very straightforward, we're going to take find measure of angle N, and I'm literally just going to take 180 and I'm going to subtract the sum of 90 plus 52. So 52 plus 90 gives me 142. I subtract it from the 180 and we get 38 degrees. So measure angle N is 38 degrees. So for number 2, we're going to have to use, let's look for finding LM, which is x. So we're going to have to use cosine, and here's why. I'm looking for this here. So I have a measurement here, and I don't have a measurement here. So what we have to do is try to figure out how we're going to do this. So this is going to be cosine, and we have a degree, so I'm going to use this degree here. So we have cosine 52 equals, and we have the adjacent, which is our x, over our hypotenuse, which is 3. So to do this, we take and we solve by clearing the decimal, or clearing the fraction in this case, and that is going to be take everything times 3. So that takes a crossover, multiplies by 3, 3 and 3 cancel, leaving x. So in your calculator, you are going to put 3, parenthesis, cosine 52 equals. So 1.85 is what x equals. I believe the calculator leaves at 1.8, but if you want to take it out to the nearest hundredth, you can. Now, step 3 is going to be similar to this. So step 3 says find sine. Well, sine is going to, now that we have the 1.2, we can use sine in this case. So for sine, we have, let me find it here, 2.4, so sine 52 equals opposite, which is y, over hypotenuse. So we are going to use sine because the 52 is across from the y, but it has a hypotenuse already labeled for us, which is 3. So for this one, you're going to do 3 times sine 52, and that's going to give us our y. So when I put this in my calculator, we are going to do 3 parenthesis sine 52, and we get 2.4 equals y. So now we have our 2 missing sides. So we know that LM is 1.8 and MN is 2.4, along with our angle that we have here. Okay, so let's look at number 10. It's going to be treated the same way, but instead of having a hypotenuse, we're only going to have a directly across. So for number 10, we have a nice little right triangle here. This is 18, this is 29. I'm going to make my hypotenuse x and my adjacent side y. So this is x, y, and z for the angles. So for part 1, we are going to find measure angle y. Part 2, we are going to find the line segment xz. And for part 3, we are going to find the, let's see here, zy. And if I'm not mistaken, I think I got these out of order. I think you have to do 3 before you do 2, because you're going to have to find your length across for your hypotenuse before you can do the other. Since I already have one of the opposites, that means sine would come before cosine. So for number 1, we are going to say, okay, I have 180 minus, well, I have 29 and 90. So 90 plus 29 gives me 119. We subtract the 2 and we're going to get 61 degrees. So that means measure angle y equals 61 degrees. So that one was very straightforward. Now, we need to do part 3 before we do part 2. So really, it should have been switched around when I wrote it. So find zy first. Well, this shouldn't be too difficult because you're going to use sine. So sine 29 equals, the opposite is 18. We do not know the hypotenuse, which is x. The reason why we had to do sine before cosine, because cosine would have 2 variables in it, because we are missing not only the adjacent, but also the hypotenuse. So that's why we had to do sine first, because we have the opposite, we just don't have the hypotenuse. So for this particular one, remember, like I said in the last video, 9.5, when you are doing these, they basically switch out. So x is going to end up equaling 18 over sine 29. So let's put this in our calculator. So I have 18 divided by parenthesis sine 29, and I should get x equals 37.1. Okay, so that's my length. Now, this is going to stand for your yz, or zy. So zy's length is 37.1. So there's one of your answers to the final question. Now, stage 2, we're going to use cosine. So cosine 29. And this time, we are missing the adjacent, but I just found the hypotenuse. So we're going to use the 37.1 as part of our calculation. Okay, so that means you're going to multiply. So 37.1 times cosine 29. And that right there is going to leave you y. So I'm going to put this over here, and we are going to put this in our calculator. So 37.1 parenthesis cosine 29 equals. So it's going to give me 32.4. And that is what y equals. So this is going to be xz is going to equal 32.4. So there are your 3 answers that you are looking for problem 10. Now, the last one has to do with setting up a diagram. So this one took me a few minutes because I had to label it. So let's recreate what they have here. This is my little boat. There we go. So there's my little sailboat. Don't laugh at my sailboat, but there you go. You have a sailboat. Okay, so we're saying that it is pulling here. There's the distance, and here is the pulley up top. So this is going up to the pulley, and then this goes straight back down. So I know that this is 12, and this is 25 for the full distance here. We do not know the angle. The angle is x. So we have to look at this and go, okay, that's basically a right angle where the two of them can join down there. We have, in this case, an opposite over a hypotenuse. So opposite over hypotenuse is always going to be sine. So we are looking at sine, which is opposite over hypotenuse. So sine x, because we don't know what it's going to be, we're just going to call it x for right now. And this is going to equal, in this case, 12 over 25. So x is actually going to be the ratio. So we're going to find the sine -1, and that's where the x comes over here, and this ratio right here drops in there. So that becomes 12 over 25 right there. So this is not really magic. If it had been cosine or tangent, either way, if you did not know the degree, you put that in place for where sine is. To get out of that, you use its inverse, saying, I have the ratio, but I don't have the degree. So that's basically what this is doing. So we put this in the calculator. So second, sine 1 is going to be 12 divided by 25, which is going to give us 28.7 degrees. That is your missing angle, and that is the end of the problem. Okay, if you have any other questions, please ask. This is basically all that you're going to do in your Chapter 9 notes. We are not doing Chapter 7 or Section 7 of this. So we are going to be taking a quiz over this in the next couple days. All right, good luck.